So this is 2019 paper 1 and this is question 7. So you've got a Camogie goalkeeper on a level pitch hit a ball straight up into the air. The path that the ball travelled can be modelled by this function. So where t is the time in seconds from when the ball is hit and f of t was the height of the ball in metres above the pitch. So the ball landed on the ground without being hit again. So at what height was the ball when it was hit by the goalkeeper? Well, when it was hit by the goalkeeper, this was the start. So this was 0 time. So put in f of 0 into your function. So minus 4 times 0 squared plus 16 times 0 plus 1. So we're looking for the height of the ball. So the ball was at 1 metre. Just put that into your calculator and you get 1. So that's 5 marks. For part B, you're asked to complete the table. So what you're going to do is go to your mode for your calculator or menu, go to 4, you're going to find the table, sub it in. And when you put in your values then, you put in your function of minus 4, you'll change that to an x squared plus 16x plus 1. You'll start at 0, you'll end at 4. Your steps will be 0.5 because of these decimals here. When you get them then, you'll get 1, get 8, 13, 16, 17. If you don't have 16 here, then you know you've done something wrong. Then 13, 8, and 1. What you can do as well is if you want on your calculator, you can put in each one into the function. So the f of 0, and then put in minus 4 times 0 squared into your calculator, plus 16 times 0, plus 1, and you'll come out with 1. So you can do it that way for each one and put in 0.5, then 1, then 1.5, and so on. But using the table function on your calculator is much easier. So 20 marks for that table. And the graph. So the graph then is just a case of plotting all of the different coordinates. So I'm plotting 0, 1, which is along here. Then 0.5 goes up to 8. You can join them as you go along if you prefer. Then we have 1, 13. Then we have 1.5, 16. Then we have 2, 17. Then we have 2.5, back to 16 again. Then we have 3, then to 13. And 13 is here. Then you have 3.5 at 8. And then you have 4 back down to 1 again. Okay, and you can label it as well. That's your graph. So the f of t equals to minus 4 t squared plus 16t plus 1. I'm just labeling it out of habit because sometimes if there's two graphs, it's hard to differentiate which one is which. So 20 marks for the table and the graph. For part C, so what you need to do is go back to your graph and find the length of time the ball was in the air from the time it was hit until it landed on the ground. So the length of time the ball was in the air from the time it was hit until it landed on the ground. So you can see that the time was so when you extend your graph, it goes down to 4.2 seconds. And when it was first hit, it was at 0 seconds. So that's a total of 4.2 seconds that it was in the air for. So that's 5 marks. The length of time the ball was 10 meters or more above the ground. So I go to where 10 is on the y-axis. I go to my graph, go down to my x-axis. I can see that it reads 0.6. And then I go across again, and I can see that when I go to x there, it's around 3.4. So I find the difference between them is 3.4 minus 0.6, and that's 2.8 seconds. And that's 4.2 seconds as well. So that is 5 marks for each one. For part D, then you're asked to find the first derivative, so the f dash of t. So the f dash of t for this question here, so you take the power of 2, bring it in front, multiply by minus 4, becomes minus 8t. plus 16t just becomes plus 16, and plus 1 becomes 0. So that's 5 marks. For part 2, it's asking you to use your answer from D part 1, which is minus 8t plus 16, to find the speed of the ball when it had been in the air for 4 seconds. Give your answer in meters per second. So what we're asked to do is replace t with 4, because the speed is shown by the function here. By finding the first derivative, that's the function for the speed of the ball, it's minus 8t plus 16. So we're looking for it after 4 seconds, so minus 8 times 4 plus 16. So that's minus 32 plus 16, which means it was minus 16 meters per second. So this just means that the ball was decelerating during that time. That is 10 marks. For part 3, use your answer from D part 1, which was minus 8t plus 16, to find the value of t for which the ball was descending and travelling at a speed of 8 meters per second. So again, the ball is changing over time, so that's why we're using the first derivative. We know that it's descending and it's at 8 meters per second, so we're actually going to use a minus 8 because it was descending. So it means it was slowing down. So we have minus 8t equals to minus 8 minus 16. So what we're going to do is solve for t. So minus 8 minus 16 is minus 24. So t then is equal to minus 24 divided by minus 8. So that means that it was after 3 seconds. So that is 5 marks for that question.